This is algebra lesson, what is this, 10.2b, right? The second day of our simplifying radical expressions. Okay, so I showed you this once yesterday. I'm going to show it to you again. What do you do when you have a big ugly one like this? We'll do like a 60 x to the fourth, y to the seventh. And I ask you to simplify this. So here, we're watching. Here's the deal. With these, when you start, first of all, the 60, how do I do the 60? You just start, remember, you just start doing it just like we were going to do it if it was by itself. So you go, okay, the factors of 60 are 30 and 2, right? We're talking about square roots here. 15 and 2, right? That 2's done. This 2's done. And then this is square root of 3 and 5. Yes? There we go. So then you look here and you go, okay, 2 times 2, or square root of 2 times square root of 2 is 2, right? It's actually square root of 4, which is 2, right? So they're gone. Cross them out. Get rid of them. They're 2. So then I pull out a 2 here, right? Does that make sense? I mean, I pull out the 2, and then that leaves me with 3 and a 5. They can't do anything with that, so it's still 15 in here. Does that make sense? The number we have like that. The x to the fourth. What can I take out of there? What times itself makes x to the fourth? X squared. Is x squared, remember what the rule is? If you pull out an even number, then you don't have to put it in absolute value because you're guaranteed that it's going to be a positive. Does that make sense? So then because we pulled out an even number here, that makes it, we don't need to put an absolute value symbol. With the y to the seventh, it has to be, we have to pull out groups of 2, right? So how many groups of 2 y's can I pull out? 3 of them, right? I mean, it's y to the third times y to the third. Do you agree? Y to the seventh, I can pull out y to the third times y to the third, which means this is y to the third over here. Oh, but that is an odd number. Therefore, this needs to be an absolute value symbol. What's left in here? A y. Because when I pulled out y, I pulled out 6 of the y's, that left me 1 left in there. Does that make sense? And so there's our solution right there. 2x squared, y to the third, an absolute value of y to the third, times the square root of 15y. Does that make sense? Okay. You guys try one. It's a little ugly. Here we go. So we're going to go the square root of 99 a b to the fifth c squared. Try it. So you're watching now. I'm going to one time break it down all the way so you can see exactly what to do here. The numbers I'm going to break down. So I'm actually going to go like this, or I'm going to pull that thing apart. What am I going to pull it apart with? Square root of 9 times the square root of 11, right? The square root of 11 is prime, so we're done. Once it's prime, there's nothing else to pull apart. Do you agree? Okay. Square root of 9, if I want to, I could go square root of 3 times square root of 3, but listen, you should recognize, what are the numbers you should recognize? 4, 9, 16, 25. This is all 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, right? Those are the numbers you should recognize. So what is the square root of 9? 3. So we're going to go down here, look what I do. I put the new square root symbol, and I'm going to put a 3 out here. I move it kind of far to the left because I need to make room for the variables that I'm pulling out. Does that make sense? So I'm pulling out the 3, that's that guy, and then I'm left with 11 inside. Does that make sense? Does that make sense to everybody what I just did? Okay. Now, they're done. He's done. I have an A in there all by himself. What times itself is an A? I have no idea, right? So the A stays in there. I can't pull that thing out. Do you agree? I can't pull it out. I have 5 B's in there. That means that it's, square root of B times square root of B times square root of B. What is the square root of B times square root of B? What is square root of B times square root of B? B, right? So then there's 2 of them. I have more times B, right? Square root of B times square root of B, which is another B, right? So then what can I pull out? There's a total of 5 B's in there. That means that I could pull out 4 of them. What times itself makes B to the fourth? B squared. So I can pull out a B squared here. Now that only takes care of 4 of these. Does that make sense? That means that's going to leave me 1 in here. Does that make sense? Now you look out here and you see that is a B squared. It's even, therefore, What? It's not, I don't need to put absolute value out there because we know it's going to be a positive number. Okay? The b's are gone because don't forget about that b in here. Now I have a c squared. What times itself makes c squared? Just a c. I pull the c out. Now listen, that is a c to the first. You agree? That's an odd number. That could be, listen, what is c? What is 25? What's the square root of 25 again? No. Plus or minus 5, right? So then no different than the square root of c squared is plus or minus c. Do you understand what I'm saying? When you pull out this c to the first, you don't put the first, you have to put the c in an absolute value symbol because it could be plus or minus. Does that make sense? And we're done. 3b squared times the absolute value of c times the square root of 11ab. Big ugly one. How many of you got that? Try again. Okay, here's a good one. Okay, absolute value, or square root of 28a squared b to the fifth. It's kind of an easy one. All right, so here we go. The 28, you got to break it apart. That makes this square root of 4 and the square root of 7, yes? Boom, I love the square root of 4. Why? It's just a 2. I pull out a deuce, right? Pull out a deuce. Okay, that means that, and I leave the square root of 7 in there, right? Gone, gone. I have an a squared. What do I pull out? An a single a. A single a, I have to do an absolute value, right? Does that make sense? I have to do that. They're gone. I have b to the fifth. What can I pull out? B squared, right? Now when I pull out b squared, that only takes care of 4 of them. That leaves me with a b inside, but I can pull out a b squared. Now do I have to put an absolute value on that? Why not? Because it's even. There's my answer. How many of you have that? 2 times the absolute value of a times b squared times the square root of 7b. You all got it? Good. I'm going to give you one more really big, ugly one. It is, I would say, equivalent to the hardest one on the page. We'll see. It's number 33 on page 615. Okay, there you go. Shh, that's not what I said. Okay, great. Okay, breaking this down. Can I break this guy, that 2 down anymore? No, but I can break this guy. It's the square root of 2 times the square root of 5. Do you agree? He's done. Okay. There's a square root of a here. Now listen, this is where you kind of have to gotta look at this, right? I mean, this is one big string of things. Do you agree? I mean, if I broke this down, this is the square root of 2 times the square root of a times the square root of b times the square root of b, right? Right? And then this is the square root of 2 times the square root of 5 times the square root of a. Big string, right? How many total a's are there? There's 6 of them. So when I pull that out, what am I pulling out? I'm pulling out 3 of them, right? So it's a to the third. I'm pulling out an a to the third. So here's I'm going to pull this again. A to the third. Ooh, odd number, right? Boom, absolute value. That means all the a's are done. Make sense? Okay. The numbers, I have the square root of 2 times the square root of 2. What's the square root of 2 times the square root of 2? 2. I pull a 2 out. That means those numbers are done. But that leaves me with the square root of 5 in here, right? And then how many b's are left? That leaves me with 3 b's. What can I pull out then? A single b. So I pull out a b. That leaves me with a b in here. And that also has to be an absolute value symbol. And I'm done. 2 times the absolute value of a to the third times the absolute value of b times the square root of 5b. How many of you got that? Does it make sense? Lou, does it make sense? The last one, let's work on this one again. What if I have this? What if I have, okay, oh. Okay, what about this one? Let's go with, let's go with, here's a tough one. Absolute value of 27 over m to the 5th. Okay, let me do it for you. Let me show you. Okay, that is the same thing as what. Well, first of all, what, and I say simplify. What are you not allowed to have? The denominator cannot have. The denominator cannot have be square rooted. Does that make sense? So this is the same thing as the square root of 27 over the square root of m to the 5th. Oops. Makes sense? You remember that? I showed you that yesterday. Okay. So then, how do I get rid of this square root of m to the 5th? What do? I multiply this thing by, what is the word? I'm multiplying the fraction by 1 in the form of m to the 5th over m to the 5th, right? I'm multiplying this by m to the 5th, square root of m to the 5th, times the square root of m to the 5th. Because what's that going to give me now? That's going to give me, what's this going to be? What's the denominator going to be now? Just m to the 5th, right? So the top is going to be the square root of 27 m to the 5th over m to the 5th. Do you agree? We're not done yet. Because what can I do with this? Is that simplified? Can I pull things out of that top? Absolutely. 27 is 9, square root of 9 times the square root of 3. What is square root of 9? 3. So that this becomes a 3 times, hold on, 3 times, this is over m to the 5th, don't forget, 3 times, what's left inside? A 3. And then m to the 5th, what can I pull out? An m squared. And that leaves me an m inside. Now, the m squared, do I have to put an absolute value symbol? No. Am I done? Can those m squared and that m to the 5th be reduced? Yes. So then the m squareds are gone. That leaves me with what on the bottom? M to the 3rd. So the answer would be 3 times 3m inside the square root of 3m over m to the 3rd. Oh, this is algebra 2. Right? This is algebra 2 for sure. This is none of this. This is not the first time you've seen any of this. We have dealt with this. Right? Try one. Try, oh, this is going to be good. Let's go 68ac to the 3rd over square root of 27a squared. There you go. So listen. The rules of fractions don't change just because it's ugly. The rules of reducing don't change just because it's ugly. The rules of square roots don't change just because it's ugly. Does that make sense? I mean, like, the rules don't change. Yes, now you're dealing with square roots. The rules don't change. The first thing we need to do is, I would say, simplify the whole top and simplify the whole bottom. Do you agree with that? Let's do that right now. Or, we could do that, or what else could we do if we wanted to? We could just clear this thing up right now and get the denominator to not be in the square root right now. Either way, you're going to have a lot of work to do. Which one do you want to do first? You want to clear it up right now? In other words, we're going to multiply this thing by 1 in the form of what? The square root of 27a squared over the square root of 27a squared. Right? What's that going to do with the denominator? It's going to become 27a squared. Right? The bottom is now 27a squared. The top now is ugly. Well, we just learned how to do that. Right? You multiply the, okay, so then, okay, let's break down 68. So we have the square root of 68ac to the 3rd. 68 can be broken down into, what, 34 and 2. 17 and 2. Those 2's become 2. Right, so we're going to pull out a 2 out here. And that leaves me with the 17 in the middle. 27. Okay, and then we have an a. We'll leave those until we're done with the other numbers. 27a squared, square root. 27 can be broken down into square root of 9 and the square root of 3. Square root of 9 is 3, so this is 2 times 3 out here. He's gone. And then times 3 in here. right? That 3 stays in there. And so now I look and go, okay, I have, how many A's are inside now? There's 1 here and 2 here. So how many A's are inside? 3. How many can I pull out? Just 1. So there's an A out here. Ooh, it's just 1. Absolute value. That leaves me with 1 A inside. And then there's 3 C's inside. How many can I pull out? 1. So I pull out C, absolute value. It leaves me with a C inside. 17 times 3 is 51. So we have 6 absolute value of A, absolute value of C, times the square root of 51AC over 27A squared. Right? What a mess. Sure can. What can I reduce here? The 6 and the 27 can be reduced. This becomes a 2, and this becomes a 9. I can reduce this A. Can I do that? Yep. I can reduce that A is gone. That leaves me with just an A down here. So it actually comes out to 2 absolute value of C times square root of 51AC over 9A. And you know what the solution is? That. Does that make sense? One last thing, I did make one mistake. Remember when I went up here and I got rid of this A? This one here? That was either a plus or a minus A, do you agree? So when I reduce that A, guess what this thing down here becomes? Plus or minus A. You know what I'm saying? Because if it was a positive, if it's negative, so then this down here is supposed to be the absolute value of A. Listen, I am very well aware that this is complex. Did anybody get this, by the way? Did you put the absolute value on the bottom too? No. Okay, see, that's tough. I mean, and that's where, like when I do math tests, it's either all right or all wrong. I don't give partial credit. I don't give one that's this complicated, but it's important that you go through this and that you learn how to do this, because guess what's coming up as a sophomore? This is going to be like chapter 2 of your sophomore year. Make sense? So you need to learn how to do this. Okay, there's actually another concept that I haven't showed you yet. I think I'm going to make this be a 3-day lesson. Does that make sense? I think I'm going to move this to 3-day lesson. So that's a bummer for me because I have to move lesson plans around, but whatever. I'm going to give you your homework again. So, okay, here we go. Your homework is going to be page 615. You're going to do number 10. Okay, hold on. I changed my mind. Okay, it's going to be numbers 615, 7 through 10 all, and 26 through 34 all. I'm not done, I don't think. And (37) through 42. I'm going to make all these even. I'm going to make your life easier because I think they're difficult. Even. Okay. You guys have about 9 minutes now to work on it. There's one more piece of this that I have to show you. I'll show it to you tomorrow.